Hi kids, we'll be going with these 3 questions from your package, like variable mass questions, like rocket based questions. We'll see that. We'll see the first question, that is 20th question from your package. A flat car of mass m0 starts moving to the right due to constant horizontal force F. Sand is spilling on the flat car from a stationary hopper. The rate of loading is constant and is equals to mu kg per second. So sand is falling at a constant rate. Find the time dependence of acceleration of the flat car in the process of loading. Friction is negligibly small. So in all these kind of questions, what you need to do is you need to visualize from the beginning. From the beginning, the mass is m0. In the beginning, the mass is m0. But what is happening with the time? With the time, you are pulling it, so it will be going ahead. At the same time, its mass is increasing. So its mass is increasing. So something is happening. So you must not take initial situation into consideration while writing the equation. We need to take some generalized situation and we need to see what will happen after some time, just after some time. So that's what we are going to do. So I am taking some generalized situation. Initial mass is m0, but I am not talking about initial mass. I am talking about after some time. After some time, the mass is m, and I am keeping on applying force, that force constant force. And by the time it might have gained some velocity v. Now in the next moment, that is after some time dt, some extra mass will be falling, that I am calling it as dm. So total mass is going to become m plus dm. I am assuming velocity will be increasing, so velocity will become v plus dv. Generally I have to put the modulus, but it is going to be positive. So even if I remove modulus, dm is going to be, mod dm is going to be dm only, mod dv is going to be dv only. So these are two instances and the gap is dt. So we know f dt equals to change in momentum. F is dp by dt. So f dt equals to dp. So f dt is change in momentum, that is final momentum minus initial momentum. Final momentum is m plus dm into v plus dv minus initial momentum is m into v. So when I expand this, I will be getting 4 terms here, but dm into dv will be very small. Dm into dv, dm is very small, dv is very small, dm into dv will be very, very small, which is almost negligible, right? Now m into v will get cancelled. So finally I will be getting f dt equals to m dv plus dm into v. I can write this one like this integration. UV rule, right? D of uv will be u into dv plus v into du, that thing. So and I can integrate on both sides. F is a constant thing, so I can take it out of integral. So integration of dt will be t. Now while integrating this, initial mass is m0 and initial velocity is 0. Final mass is m and final velocity is some v. Now how to find final mass? They have given, yes, they have given dm by dt is constant mu. From there when you integrate, you will be getting mass as m0 plus mu into t. After any time, mass is going to be mu m0 plus mu into t. So initial final mass into final velocity minus initial mass is m0 into initial velocity is 0, right? Now I could have written this equation directly in the first place, because I know if I take cart and sand as my system, then f into t will be change in momentum of my system. Initially momentum of my system is 0, finally momentum of my system is total mass into v. Anyway, after writing this, we will be getting velocity, right? If you can bring this to the left hand side, you will get velocity. When you differentiate velocity, you will be getting acceleration, right? So that's the idea. But someone was telling me about this thing, like you can substitute mu equals to 0 and you can eliminate the options. Like I don't want to take the name, but credits for that, right? Okay, if mu is 0, what will happen? You can check. If mu is 0, no, nothing is falling, so you are applying a constant force, the acceleration is going to be f by m. Substitute mu equals to 0 and see which option will give you f by m0, and that is going to be the answer. And luckily in this question, you will be getting the right answer by eliminating those options. Now the next question, going to the next question. A rocket has a mass of 21,000 kg, of which 15,000 kg is fuel. So rocket's body mass is 6,000 kg. The rocket engine can exhaust fuel at a rate of 190 kg per second with an exhaust velocity of 2,800 meters per second related to the rocket. If the rocket is fired vertically upwards, calculate its final velocity at the burnout. Burnout in the sense entire fuel is consumed. Assume that the acceleration due to gravity is constant, that is g is 9.8, and there is no air resistance. Again what we will do is, we don't visualize initial situation, we don't visualize final situation. Initially mass is 21,000, finally mass is how much? Initially mass is 21,000, finally mass is 6,000. Initially mass is 21,000, finally mass is 6,000, but we don't take either initial situation or final situation, we will take any generalized situation. So when the mass is m. Now when the mass is m, it has some velocity due to that exhaust thing, because when it is throwing the gases out, it will be gaining some velocity in the forward direction kind of thing. Now there is some external force, that is gravity on my system. If I take this mass as m at any moment and velocity is v, in the next moment, what's happening? Some of the mass is going out, that I am calling it as mod dm, So some of the mass is going out, so that mass is mod dm, so the leftover mass will be m minus mod dm. Now I am visualizing this velocity is increasing, so v plus mod dv. Now relative to this velocity is u. So the meaning is, if this guy's velocity is v plus mod dv, this guy's velocity will be v plus mod dv minus u. This guy's velocity will be u less than this guy's velocity, right? So yeah, this guy's weight will be m minus mod dm into g, this guy's weight will be mod dm into g. The total weight will be same as this weight. So basically, if I take this as my system, there is external force, that is mg, acting in the downward direction. Now let me talk about this modulus things first. Velocity, I am assumed it is increasing, so dv in the sense final value minus initial value, that is going to be positive. So if dv is positive, mod dv will turn out to be dv itself. But what is happening to dm? Mass is reducing. So dm is final minus initial, that is negative. dm is negative value. So that is the reason I have put modulus there. Now if dm is negative value and if I remove modulus, what will happen? It will become minus dm, right? This is negative value, so when you remove modulus, it will become minus dm. So this is minus of negative value, which will turn out to be positive, right? Yeah, so that's the idea. Now again, f dt equals to change in momentum. F dt, mg dt in the negative direction equals to final momentum minus initial momentum. That you manage by yourself. You can put modulus and you can remove that modulus, you will get this equation. Make sure you are getting this equation. If you are not getting this equation, then you can come to me, I will explain how this equation came. But do it properly. At least when you come to me, at least come with this figure, right? So when you do that final momentum minus initial momentum, you will be getting this equation. Now after expanding, these two terms will be getting cancelled. Now you need to find velocity as a function of something. You need to find final velocity, right? So I am bringing, mdv is here, but this m is also varying with time. So I am bringing this m to the other side. It's only about integration. This is the only equation you need to care about. Remaining entire thing is only manipulation. I have written f dt equals to dp. Right? Now this is given in the equation. You can use this kind of information in the previous equation also, where I have written m naught plus mu t. Here it is m naught minus mu t. Right? I can integrate. Now some people, what they do is, they will divide this equation with dt and dt, and they will show like this is nothing but gravitational force which will be in the downward direction. This will be the thrust force which will be in the upward direction, that is dm by dt into u. Magnitude wise, it is mod dm by dt into u, and direction wise it will be in the upward direction. Some people will call it as thrust force, anyway that doesn't matter. Now you will be integrating. Initial velocity is 0, final velocity is v. Now time taken, what is the time taken? So initial mass is 21,000, final mass is some 15,000. So initial mass is 21,000, final mass is 15,000. So time taken will be 21,000 minus 15,000 by mu, right? And integration, initial mass, final mass. So substitute the values, you will be getting the answer. Mu value is given, constant rate. Exhaust velocity, u is called as exhaust velocity, that is also given. You just substitute the values, you will be getting the answer. In every question, the only thing is draw this figure, and the time gap is dt. Now f dt equals to change in momentum, write that equation, solve it, you will get the answer. If you want, I will show you in the next question also. A rocket of mass m naught has attained a speed equal to its exhaust speed, and at that time the mass of the rocket is m, then the ratio of m naught by m. So what we will do? We will again, at any generalized moment its velocity is v. In this question gravity is not there, so I can directly conserve momentum, or I can write f dt is 0 equals to dp, that is p final minus p initial. P final minus p initial is 0, or I can say p initial equals to p final. So I have directly written. So mass is decreasing, so mod dm, and I assumed velocity is increasing. With respect to this guy, exhaust velocity is u. So the meaning is, when compared to this guy must have less velocity of u. So if this guy's velocity is v plus mod dv, this guy's velocity will be v plus mod dv minus u. So final moment, yeah, again dv, this is increasing, so mod dv will be positive, so mod dv is going to be same as dv, but dm is negative, so mod dm will be minus dm, right. Now final momentum, this is the initial momentum, this is the final momentum. Remove the modulus, substitute the values, mv will get cancelled. Initial momentum equals to final momentum. This is the only equation you need to understand, or else you can write it as f dt equals to change in momentum. Then bring one variable to one side, other variable to other side. When the mass is m naught, velocity is 0. When the mass is m, its velocity is equals to exhaust velocity magnitude wise. Then it's only about solving, right? Thank you.